Hello and welcome to STR IAS. So, in the previous lecture, we have seen about the crust, the topmost layer of Earth. So, if this is the topmost layer of the Earth, then until in the oceanic crust, it will be from 5 kilometers to 30 kilometers, and continental crust will be 50 or 70 kilometers. So, after that, we will be having one discontinuity called Moho discontinuity. So after Moho discontinuity or Mohorovicic discontinuity, we'll be having the second most layer of the earth called mantle. Okay, so today we'll be looking at mantle. So just like before, crust we have seen. So what percent of volume it will be occupying. So we will be seeing about mantle's volume also. Volume of mantle will be 83% of Earth's volume. So it is the most biggest layer by volume, right? So we have seen like crust is around like 0.5 to 1% of volume of Earth, but mantle is around 83% of volume of Earth. It forms around 83% of volume of Earth. And also, what about the mass? If mass of mantle is around 67% of mass of Earth. So volume wise biggest and mass wise is also biggest, right? So from where it will be till where? So it will be from Moho discontinuity till 2900 kilometers. So what is the extension? The extension is from Moho to 2900 kilometers. Then we have to see about density. So density varies, right, from upper mantle to lower mantle. So for upper mantle, which we call as asthenosphere, the density is 2.9 to 3.3 gram per centimeter cube. Then density of lower mantle is 3.3 to 5.7 gram per centimeter cube. We have seen like what is the average density of Earth. The average density of Earth is 5.1 gram per centimeter cube, and density of crust is around 2.7 gram per centimeter cube. So upper mantle is little more greater than crust, right? 2.9 to 3.3, and lower mantle is 3.3 to 5.7. And average crust of Earth, average density of Earth is 5.1 gram per centimeter cube, right? Then we have seen the composition of crust, right? With the help of OSI. Now we'll be seeing the composition of mantle. So mantle's composition can be remembered with the help of MOMS. M for mantle, O for oxygen, M for magnesium, S for silicon. So silicon is 21%, okay, magnesium is 23%, and the remaining 45% will be iron. Then what about the temperature? We have seen like for 1 kilometer it will be ranging, it will be increasing 30 degrees Celsius in the crust, right? And average temperature ranges from 200 degrees Celsius to 400 degrees Celsius in crust. But what about mantle? So the temperature of mantle in the upper boundary of crust, it will be around 200 degrees Celsius, but till 2900 kilometers, the temperature reaches 4000 degrees Celsius at mantle and outer core boundary. So what will be the temperature? 4000 degrees Celsius. And on the upper mantle, nothing but asthenosphere, we can see convective material circulation, okay, which helps in tectonic movement of plates. So the upper part of mantle or upper mantle is called asthenosphere. So we'll be looking about asthenosphere now. So astheno means weak. It is just below the lithosphere, extending up to 80 to 200 kilometers. So it is from 80 to 200 kilometers, and it is highly viscous, mechanically weak, and ductile. Can be drawn into tubes or sheets or wires. That is the meaning of ductile. Okay, so asthenosphere, astheno means weak. It is from 80 to 200 kilometers, and it is highly viscous fluid. Mechanically it is weak, and it is also ductile. So its density will be more than the density of crust, 2.8 kante more than 2.8. The properties of asthenosphere. So these properties will help asthenosphere to move. That movement is called tectonic movement, and also it also will be leading to isostatic adjustments. For example, we can see that if it is a crust, there will be a movement of fluid like this. Okay, so there will be a movement of fluid like this. If two plates are there, if the biggest plate comes here and if it submerges the lowest, heavier plate comes and submerges the lightest plate, the lightest plate, it will be getting submerged and it will be covered by this asthenosphere fluid, and this is called isostatic adjustment. It is nothing but one part of the crust area is counterbalanced by the depressed part, so or submerged part, and this asthenosphere is main source of magma which we see in volcanoes. Okay, so this is all about mantle. So what we have seen, mantle, what is the volume? Volume is 83%, mass is around 67%. It ranges from Moho to 2900 kilometers, right? And its average density of upper mantle, nothing but asthenosphere, is 2.9 to 3.3 gram per centimeter cube, and inner mantle is around 3.3 to 5.7 gram per centimeter cube, and temperature ranges from 200 degrees Celsius to 4000 degrees Celsius. 4000 degrees Celsius is near outer core, and the upper layer is called upper layer of mantle is called asthenosphere. It is highly viscous, mechanically weak, and ductile. It will be leading to tectonic movements and isostatic adjustments. And we can see that asthenosphere is the main source of magma, which we call as lava after coming out of the vent of volcano, right? So in the next lecture, we'll be seeing about core.